To help us think about the graphs of logarithmic functions, let's consider the function f of x equals the logarithm base 2 of x and make a table of points to help us determine what the graph might look like. If we put in 2 to this function, we would have the logarithm base 2 of 2, which is 1. If we put in 4 for this function, we would have the logarithm base 2 of 4. 2 to the second power is 4, so our answer would be 2. When we plug in 8, the logarithm base 2 of 8, 2 raised to the third power is 8, so the answer would be 3. If we put in, for example, 1/2 for x, the logarithm base 2 of 1/2 would be -1. 2 to the -1 is 1/2. Or if we put in 1/4 for x, 2 to the -2 would be 1 over 2 squared, which is 1 over 4. One more important point I would like to add here: if x is 1, the logarithm base 2 of 1, the logarithm of 1 is always 0. So let's see what it looks like when we plot these points on our graph. We have a point at 2, 1, at 4, 2, at 8, 3, 1/2, -1, 1/4, -2, and 1, 0. You might be able to see the pattern here that the graph will start close to the y-axis and then slowly but gradually keep increasing as you move towards the right. My hand is a little shakier than it should have been, but that's approximately gives you an idea of what a logarithmic graph would look like. So let's keep in mind some of the properties of graphs. First, we're asked what is the x-intercept of our graph. And we can see that this graph crosses the x-axis right there at the point 1, 0. And the asymptote, the line that the graph gets close to, is the y-axis, which in equation form would be the vertical line x equals 0. In general, a function of the form f of x equals logarithm base b of x will cross the x-axis and have an x-intercept of 1, and will have a vertical asymptote of x equals 0. You might remember when we were graphing exponential functions would often have a y-intercept of 1 and a horizontal asymptote of y equals 0. A logarithmic function such as this has an x-intercept of 1 and a vertical asymptote of x equals 0.